Okay, so for example 2, for parametric slopes, we have the following problem. The position of a particle is given by the vector t to the fourth minus 4t cubed, comma, t cubed minus 6t squared plus 9t. So when you're given this vector notation, the first really important thing to notice is that this is the same as the notation we've seen before, just it looks different. So this first coordinate represents the x of t, right? And the second coordinate represents your y of t. So we still are given x of t and y of t, we're just given them slightly different in format, right? So we have x of t equals t to the fourth minus 4t cubed, and we have y of t is t to the third minus 6t squared plus 9t. All right, so that's the first mental leap we have to make, right, is the different notation. The second mental leap we have to make is we need to think about what we're asking when we ask about a horizontal tangent. So remember that horizontal lines are lines that look like this, for lack of a better explanation, right? They have no rise and lots of run, right? They go on forever, left and right, but no rise, lots of run. So if we picture what slope is, given that it's rise over run, we're looking at 0 over some number, meaning a horizontal slope is a slope of 0, right? So that's not super mathy notation, that's just some logic, right? So again, just logic, not mathy notation. So once we know that a horizontal tangent line is a line that has a slope of 0, we say, okay, cool, so I need MT to be 0, right? That's what it means to be a horizontal tangent line. And we know from our last example and also from the lesson before that, that the slope of a tangent line for a parametric curve is y prime of t on top of x prime of t, right? So we essentially need that to be 0. So you might think, okay, well, that's cool. I know what happens when fractions equal 0. It really just means the top is 0. That's mostly true, right? But the third mental leap, right? So mental leap number 1 was the notation. Mental leap number 2 was the definition of horizontal tangent. Mental leap number 3 is to recognize that what we're really looking for is when y prime of t is 0, but x prime of t is not 0, right? That's the problem, is that we can't, and the reason is because 0 over 0 is what we call an indeterminate form. It doesn't function the way other stuff functions. So we don't want 0 over 0. So essentially, to do this problem, what we need to find is we need to find where y prime of t is 0. We also need to find where x prime of t is 0. And then we need to make sure that our answer is only the places that y prime of t is 0, but not x prime of t. So let's go ahead and start working on that. So my x of t was t to the fourth minus 4t cubed. X prime of t will be 4t cubed minus a 12t squared, which means I have a GCF of a 4t squared minus times a quantity t minus 3, my bad. And that should be 0, right? We're trying to find when that's 0. So either 4t squared is 0, meaning t is 0, or t minus 3 is 0, which means I get t is 3. So those are the two times that x prime of t is 0. And remember, just as a side note, we want when x prime of t is not 0. So we don't want our answer to be either 0 or 3. What we do want is we want when y prime of t is 0. So my y of t was t cubed minus 6t squared plus 9t, which means my y prime of t is going to be 3t squared minus 12t plus 9. There's a nice GCF of 3 there, and I can take out a t squared minus 4t plus 3. So what I end up getting is that my y prime of t is a 3 times the quantity t minus 1 times the quantity t minus 3. So since I want when that equals 0, either 0 equals 3, which is a big fat lie, because 0 is not the same as the number 3, or t minus 1 is 0, which gives me t is 1, or t minus 3 is 0, which gives me t is 3. So we do want when y prime of t equals 0, right? So what we're looking for is the answers that occur here, but don't occur here, and the answer that I want seems to be t equals 1. So over here, my answer is going to be t equals 1 only. Again, the reason why is because at t equals 3, which is my other candidate, x prime of 3 is also equal to 0, and 0 over 0 is an indeterminate form.